Today we're going to talk about loops and lists. Loops are something we haven't been able to do yet in Python, right? We want to have our code come back around on itself. Here, let me fix this. Boop. Just like that. So you got code, and you'd like to repeat these two ideas, right? Come back to it as many times as you want to. You want to loop around. So that's what we're going to do today, among other things. All right. So the first thing I do want to talk about is errors in Python, because you've probably been getting them as you were trying out your assignment, right? Stuff like that. So you're gonna get yelled at by Python. The more Python you write, it's just inevitable. I get yelled at all the time too. But there's two kinds of errors. There's a way to speak Python wrong, right? And there's two main kinds of errors in a Python program. Oops, I got something caught in my water bottle. Until I fix it. There we go. There's two kinds of errors in Python. There's one called a runtime error. That kind of makes sense. Hopefully it means like your program is running and then it discovers that something's wrong. So it's an unrecoverable error. Runtime error is. It's unrecoverable and it happens right as your program is running. Python can't figure out that a bad thing's going to happen ahead of time. It just has to let the program run, and eventually the program fails. So that's going to be a runtime error. And the program's just going to stop. It's going to give up when a runtime error happens. So I think the easiest example of a runtime error is when you divide by 0. So let me make a program that divides by 0 in idle. And that would be a runtime error example. So the program is going to be allowed to run by Python because it's not going to know ahead of time that there's an issue, but the issue will happen. All right. So I'll make a new file. I'll call it runtimeerror.py, but what folder name do I want it in? I guess we're lecture 19 today. So let's see, let's make a folder for that. Runtimeerror.py, there we go. So here is a simple program that's going to mess up, that Python just can't tell ahead of time if there's an issue. There we go. Division by 0. So let's make that program. I will ask the user for a number. This will be where the runtime error is going to happen. So I'll ask the user for a number. Hey user, input, enter number. Colon space. All right, and then I'll shove that into as an integer. I'll convert it to an integer and shove it into a variable called n. Let's say. So I've got a number n from the user as a whole number, and then I'm going to print. Here's where the issue will arise, right? I'd like to print 42 divided by that n. Okay. So we'll make it pretty. We'll print like 42 slash space with a comma. We'll use multiple arguments to print. So this will print 42 slash n and then the answer, 42 divided by n. All right. So let me run this. And sometimes, like Python's going to let this program run because a lot of the time, whatever number the user types is probably going to be a normal number. Like the user could type 2, and then it will divide 42 by 2, right? Oh, I need to type like is or something. Is colon space. Right? Is something. So if I rerun it, like if you divide 42 by 2, you get 21 and it's happy, right? But do you see that the user could have typed 0? The user could have typed 0. The Python program doesn't know ahead of time. It's not magic. It doesn't know what number the user is going to type. But if you type 0, it's going to try to divide 42 by 0, which of course is undefined. And we're going to get an error, all right? It says 0 division error, division by 0. It's as helpful as possible. I'm sure you've seen errors like this before. It tells you what line it's on, which is nice. You can see line 2, and down at the bottom here, a very small font, it shows you what line you're on, line 2. So it's this line was the issue. It prints it out as well. And it's like division by 0. So, okay, there was one divide operation here. That must have been the problem. And then you go and try to fix it. Okay, maybe you could have asked the user and like used an if statement to check if they typed 0 or not. But this is a runtime error, right? It's a problem that happens as the program's running. It was running for a second, and then it stopped because we hit an unrecoverable problem, all right? And runtime errors stop the program. So like if we were to type hello after this, with a normal like a normal run of the program, you type 2 or something, it does the work, and then it continues down here. But the second there's a runtime error, like on this divide by 0, the whole program stops. So I do 0 again, see that we get the error, the program's done, I don't see hello anymore. Okay, so that's what it means to be a runtime error. It's an error that just happens as the program's running. Python's not smart enough to guess what the user might have typed, so it's going to allow the program to run, but it might fail, right? And so it'll stop with an unrecoverable runtime error. Does that make sense? I'm sure you've seen one of those by now. Let's see here. Or at least you've gotten read from Python. Like you even sometimes you type your program wrong and it will tell you that there's something wrong even before it runs. That's another kind of error. And then the third, I guess, kind of error, if we consider that other one to be a different kind, the third one is called a logic error. All right, a logic error is very, very subtle. The program's going to run. It's going to run to completion even. Another word for logic error is bug. Okay, so we know what a bug is, hopefully. It's just when you have something and you mean to do one thing, but you get the wrong answer. Right? So your program does it wrong somehow. There's an issue with the logic. It's a bug. So here's like my simplest example too of like a logic error. Let's set the I variable to 42, and then I'll make a new variable called like I plus 2 and set it to the result of doing I plus 1. Okay, you see how your program's probably going to run. It's probably not going to do anything wrong. It's not going to have a runtime error, but it's just like the number that you expect it to be in this variable is obviously not what it should be, right? It should be I plus 2, but it's holding 43 rather than 44 right now. Does that make sense? That's a bug, and you probably will need to change it, and those are the hardest ones to track down because you just get the wrong answer and you have to go back and like print out all the thought processes in your program, like why did this happen? Okay, so those are the two main kinds of errors in a Python program. There's secretly a third kind where like you mess up the indentation or something. It does yell at you for those kinds of things, but that's less common once you get more practice with Python. All right. So the next thing I want to teach you is called lists. It's a way of holding a bunch of stuff at once in a single variable name. All right, so that's pretty nice. A list holds a bunch of stuff in a single variable, and the order matters. So let's say, I don't know, we wanted to make a video game, a three-dimensional video game where like your enemies in your game, for example, they could be in the virtual world, the 3D virtual world anywhere, and you want to store like where they are right now so they can move around and attack your character or whatever. And so maybe your enemy right now is flying, and it's at these 3D coordinates, right? You have X, Y, Z coordinates. It's at like 2, 3, 5. So 2, 3, and then up 5. 1, 2, 3, 4, 5. 3 dimensions. So this is where your enemy is, out in space. Okay, so they're going out this way, up in space, and this is coordinates 2, 3, 5. 3D coordinates. You would like to store that somewhere to know where your enemy is, so like you can move it and change its coordinates and stuff in your game. Right now, what you have to do is you have to have 3 separate variables, right? It's kind of disgusting. You have to have like an X, Y, and Z coordinate variable. 2, 3, 5. That gets a little disgusting, even more disgusting when you have multiple enemies or something. You also want to keep track of where your character is. Like you have a bunch of like X1, X2, X3, Y1, Y2, Y3, a bunch of different points all held in separate variables. That's no fun. All right, a list is a way to hold on to a bunch of stuff all at once. All right, so here's what a list looks like in Python. You use these angle brackets. Sorry, not angle brackets, square brackets. Use the square brackets, and then you put comma separated all the things that you want in your list. It's just one big chunk of things all together. So this idea is like, I'll read it like this. It's the list 1, then 2, then 3, and the order is important. All right, so you could set that, like that syntax is Python syntax, 2, 3, 5, or 1, 2, 3. Like to make this point, you could shove that list into a variable, right? And it's just has one name for all those pieces now. So P holds all together the list 2, then 3, then 5 in that order. All right, so this is 1, then 2, then 3 in that order. All right, so a list is one thing as far as Python is concerned. It's a single thing, single chunk of data, which is really nice. All right, so let's you can set it into a variable just like I did here, and then you have your coordinates for your enemy or your character or whatever. Okay, so let me show you that. Let me show you the brand new type. So technically a list is a cloud. It can have inner types, right? It can be a list of numbers, a list of floats, a list of strs even. So I'll make a file called lists.py, and so I can do this. P equals square brackets 2, 3, 5. All right, and so that's now the list. If I just say print P, it'll print out the whole thing because they're all together in a thing called a list. All right, 2, 3, 5. Isn't that beautiful? And you can print. It's a new type too. The type of P. What is its type? If you print it, it's a list. And of course, there's smaller types inside. Like each piece of the list has an int, but the whole thing is a list. The whole type thing is a list. So yeah, you can make lists. Let me just do it in the REPL really quick. 1, 2, 3. You can make a bunch of lists. 1, 2, 3, 4, 5, 6, 7. Spacing doesn't really matter. If you're coming from another language, if you've already learned another programming language, you can do this in Python. It will make you feel a little bit uneasy. 4, 5, 6. You can do that in Python. It doesn't have to all be the same type of things, but usually you probably keep it the same type. A, B, C. A list of strs, a list of ints, and then a list of different types together. Okay, so you can have all those things. And so it's a one-stop shop for a bunch of stuff at once. Okay, so now you might be asking, well, all right, it's the whole thing. It's 2, then 3, then 5 in that order. How do I get out the pieces? So let's talk about that. All right. So we know how to make lists. Like you can give up all the pieces of a list in order like this. That's fine. Or you can build lists from smaller pieces as well. You can make lists from scratch if you would like. There is an empty list. That's just a open bracket, close bracket. And you can also add two lists together. The plus operation works for lists. So if you have this list, 1, 2, and you add it to this list, 3, 4, Python will give you back this list. 1, then 2, then 3, then 4. It'll build it up and make it bigger. Okay, that's totally a thing. Let me show you that on the REPL. Like 1, 2, that list, plus 3, 4. It builds up the whole bigger list with just all the pieces all right next to each other. Okay, those pieces, by the way, are called elements. We call these elements of the list. All right, and you also can have an empty list. So you can start from emptiness. You're like, all right, empty list plus the list with 1 plus the list with 2, and that just builds 1, 2 because the empty list kind of doesn't count. It's like the 0 of list addition, but I mean it's there. It works, and then you can add them. So Python lists, they also know their size. You can ask for. There's a special built-in function called len that gives you back the length of the list, the size of it. And so if you say len, and then you give it a list, either as a variable name or just all together at once, 1, 2. So this list has 2 things in it, so len will give you back the size of it is 2. The length of that list is 2. Okay. So let me show you that. So this list, this p list, if I print its length, print the len of p, it'll be 3, right? Because there's 3 things in it. So that's nice. You can build up lists from smaller lists and smaller things, and you can tell how big it is, but I still haven't told you how to go inside of it. Like, I want the y coordinate right now. How do I get out the 3 from p? Let me show that to you. All right, it has to do with indexes. All right, so there's, or I guess indices. Sorry, is the correct plural. Indices. So at your list, you can talk about each individual piece, and every piece is called an element, by the way. They're called elements. And let's say I had this list, x equals the list 5, 6, 7. Here's how I want you to think of it arranged in memory. It kind of looks like this. X is like this, and it's got the 5, then the 6, then the 7. It's like a bunch of boxes right next to each other. And they're in that order, and they all have an associated index. All right? So you can use those indices to get things out. So they start at 0. Everything in computer science starts at 0. And so the index of the very first thing on the list is 0. So the 5 is at index 0, the 6 is at index 1, and the 7 will be at index 2. All right? So if you wanted the first thing, you go to the 0th index. And here's how you go. Here's how you do that. You say the name of your list, and then you give the bracket-like syntax, but you give inside of it the index that you want to go to. So you're reusing that syntax. So if you want to get out the 5, for example, from the list, you'd say x, take the list x, go to index 0. That's how you read that kind of syntax, all right? And that will give you back the 5. It'd be like x, go to index 2. That'll give you back the 7. Yeah. So that works. And there's also a second set of indices for every list. They also go backwards. So if you want the last thing, you can fiddle with like the length to like figure that out manually. Or the easier way is just to use that the last index in any list is always going to be -1. So there's always 2 valid indices for every list element. This is also -1, just means go to the last element. That's the last element, so that's at -1, that's at -2, and that means the 5 is also has -3 as another valid index that you could go to, okay? So -1 is always the last thing. So x of -1, what does that mean? That's just another way to get back to 7, right? You're there, x of -2, That's another way to get out the 6. You could have gone to x of 1, index 1, or negative 2. They're both pointing you right here. Okay? That's kind of cool. Are there any questions about that? Like, that's how you can get pieces out of a list. All right, so let's show that in code. So I got this p list, 2, 3, 5. So index 0 is 2, index 1 is 3, index 2 is 5. Or you could use the negatives. All right, so we got print p of 0. That's going to print out the 2. All right, it's going to go into this piece is the 0th element, index 0, and get it out. And then p of 2, we'll get the 5, right, because it goes 0, 1, 2. This is the 5's at index 2. And then let's print the 3 using the negative 1. So this will be, the last element is negative 1, so the second to last element is negative 2, the index. Could have also been 1, right? So there's my 2, 5, 3. I'm getting them out in that order, all right? So remember that p of negative 2 is the same as p of 1 for this list. Depends on the size of the list, which ones like correspond like that. But this works for a size 3 list. And then, yeah, there's that. What else do I want to show you? You could also go in and use those indices to set stuff. Okay? So if you want the first element, you can get it back like this, or you could set it. You could put this syntax x of 0 on the left side of an equality, on the left side of an assignment statement. So you could do this. You could say, hey, p of 0, I know that you're 2 right now, but I'd like you to be 7. Right? So that same syntax works. So use the same syntax to change an index's value. All right, so now if I print p again, I've changed the 0th element. It's not 2, 3, 5 anymore. It's now going to be 7, 3, 5. So I did that. So I rerun it. Now it's 7, 3, 5. Cool. All right. So that's lists in a nutshell. Does that make enough sense? All right. So here, let me show you this code just for a split second. And I have a question for you now. So I guess you can go to the, let's do the written nice page, why not? But you guys can get into groups and elect a leader, but here's your question. Let me stop, I'll stop attendance after we finish that too, so make sure to do that. Let's do written nice and I'll clear it out for us. Cool. So I'd like you to say that we have a list called capital L, this big list, we've shoved it into a variable called L, and I would like you to write down the 2 different ways that you can get this 5 out. How can you get that 5 out of that list? There's going to be 2 valid indices, see if you can remember which ones they are, and convince your neighbors that you are correct. All right? So give that a try, shouldn't be too bad, just takes a little while, and enter in your answer, please. I'll give you a couple minutes. How would you get the 5 out? Here's some good thoughts. Is that enough time? We're having a detailed discussion in the back. I'll give you another 30 seconds to enter in your answer. There's going to be two ways, right? It's print blank and then print another blank. What should those blanks be now is the question, I guess. All right, let's come back together and take a look at what you guys are thinking. I see that one group is thinking 3 and -4. And let's see if we're right. Let us see. So let's count. All right. So remember the indices are always going to start at 0. So that 8 then is going to be at index 0. Then 1, 2, 3. Good. So it's going to be 3 there in that order. And then 4, 5, and 6 for all those. And then if you wanted to go backwards, -1 will always be your last index. And then you work your way from the other end. So the second to last thing is -2. Third to last is -3. That's kind of how you can remember. The fourth from last is, that's another one for your 5. You see that? -5, -6. The seventh from last is also the first or 0th thing. Okay, so if you wanted the 5, you have two indices, that are going to be your options. You can go to L of 3, remember that syntax, these bad boys, or L of -4. Does that make sense? That'll be the secret. All right, so thank you for your thoughts, and let us continue. So if we are good with lists, I'm ready to teach us loops. Are you ready? Well, let's do it. So again, loops are the idea of we have some code and we want to come back around on it. We want to repeat it. Boop. A bunch of times until we're done, until we give up. Okay, so what did loops look like in Scratch, right? It was like, all right, we had something that looked kind of like this, right? The most generic loop that we had was like a repeat until loop that, here, I need more room, don't I? It took a pointy thing, kind of, and then it took like whatever you wanted to repeat in there, and then it took like, some of them took a conditions like keep on going until this is true, until that is true. And then it took all the things that you wanted to keep repeating as long as that thing wasn't true, right? So we want to try to translate that into Python, and it's going to look very similar to our if statements. It'll have like a keyword, and then it'll have a pointy thing, and we'll put our condition there, and then we'll put a colon, and that's the way we can like delimit like what is the inside or the body, right, of that loop. We're going to indent and give all the different pieces that make it up. Indent as many times as we need, with as many lines of code as we'd like to have repeated. Okay, so that's what they're going to look like essentially in Python. But yeah, let's spell it out slowly. All right, so you do already know these guys. So let's see here. What do I want to do in code? Give me a second. We will get there. So yeah, you do already know these. Just like in Scratch, what's going to happen is that a loop is going to repeat a bunch of code, but it's going to be slightly different than that repeat until. I want to teach you essentially the equivalent of the repeat until. It's going to be called a while loop in Python, all right? It's going to be a little backwards, okay? So what's going to happen in a while loop, I'll show you the syntax soon, but what it's going to do is going to execute the body, which is the code that you want repeated. It will execute its body as long as its condition is true. So it's like, while this thing is true, do this, rather than repeat until it's true. So while this thing is true, keep going. All right, so it's a little bit backwards to the repeat until, but this is how it's going to work. That's what a while loop kind of executes like. It's going to have a condition to always check, and it will run the body of your loop as long as that condition is true. As long as it evaluates to true, you can repeat your body of your loop. And that's as many lines as you'd like to have repeated. And then it always goes back and keeps checking the condition, right? So as long as the condition is true, this is how a while loop is going to execute. It's always going to repeat its body, right? The second, though, it becomes false, then it's done with the loop. It stops. All right? The second it becomes false, it will just continue with the rest of your code, all right? All the unindented stuff. And so I still need to show you the syntax, but like that's how it's going to work, right? You'll have a condition, and then it will repeat the body as long as that condition is true and stop once it's false, right? So here is what a while loop looks like. Here's how you make one, all right? It's very similar to if. So you're going to say while, and then you're going to give your condition, whatever it is, something that becomes true or false, right? And then you're going to give a colon, and then you'll tab over, right? Your idle should do this for you. You'll tab over, and then you put on the same level, right? Indented, 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 as many lines as you want repeated, as long as the condition is true, right? So this is the body, we call it, of your while loop. Of the while loop. All right, so it looks very similar to an if. And yeah, so while that condition is true, it'll keep running this body. It'll check the condition, run the body. As long as it's true, it'll keep coming back, keep coming back. And eventually, hopefully, the condition will become false, in which case it stops the loop and it just keeps on going to whatever the unindented stuff is. Just like an if statement, it does that. So yeah, while it's true, it'll execute the body. So like this is the diagram for how it's going to work. And yeah, the second it becomes false, you are done with that loop. All right. So that's kind of like the most general thing. If you wanted to make a loop that runs forever, like the equivalent of a forever loop in Python, what's the easiest way to make a condition that never becomes false, right? Because as long as it's true, it'll run the body. So just keep the condition true. You can say this, while true. This is a forever loop in Python. Because as long as that condition is true, and true is always true, right? It'll run the body. So this is a forever loop, right? So always gets executed. Always gets executed. So that kind of makes sense. So you say like this condition will always be true, never false. So it'll just keep running the body and keep rechecking. But true will always remain true, of course. That's a forever loop in Python, right? While true. Let me show you that first. This one. Forever loop.py. Did I spell forever right? Yeah. So I'll just say while true and do something. While true, I'll say like hello world. All right. And the whole point of a forever loop is like it's always just going to keep running the body forever and ever and ever until the end of time. It will never stop, right? While loops, usually you expect them to stop and like you unindent and you have like code down here that runs after the while loop's over. But because the while loop will never end, we will never get to this code. You see that? We can never get here if this is a forever loop. It'll always run its body forever. So watch. It's going to print hello world a million times right now when I run this. Whee! There it goes. And once you're tired of it, you can press Control-C. It's supposed to stop it. But I wasn't fast enough, and so my program just ran out of memory. Or idle itself ran out of memory, so I need to fix that. Good old Python. Stop, please. So, yeah, you can either... Usually if you press Control-C, it's Control-C fast enough, it'll stop the program, but I was not fast enough, all right? But if I was, that's what you would have done, all right? But that's a forever loop in Python. Let me reopen idle. Usually you want a program that eventually, like a loop that eventually stops. And so you'd have some fancier condition that's sometimes true, or usually true at the start, and then eventually becomes false. Okay? So that's the goal. Let's iterate through something now. Let's do some examples of like counting and stuff like that, just like easy examples that we started learning when we learned about loops in Scratch, right? So let's print the numbers from 1 to 10 in order, right? So that first 1, then 2, then 3. Right now, you'd be able to, you only know how to do something like this, right? Print 1, print 2. That's disgusting. We want to be fancier than that. Okay, so we don't like this anymore. We're going to use a loop instead. We use a while loop. And so here's kind of the setup. Here's the algorithm to print from 1 to 10. It's going to be exactly the same kind of as in Scratch. We're going to use some variable. I'll call it I, because we're iterating, right? And we'll start that I variable at the first thing, let's say that we want to print. So it'll be 1, okay? So we'll start I at 1, and then what we want to do is repeatedly do the following. So to keep on printing as long as it's less than or equal to 10. So we want to print I, like it'll print the 1, right? And then get ready because we want to wrap around and do the same code. So make I 2 for next time. Print I and then increment I. All right. So that's going to be the game, right? Print I, print your 1, and then increment it, make it 2. Then print 2, increment it to make it 3. See if we looped that? These 2 lines of code, essentially, if we looped those enough times, we get from 1 to 10. Print 3, increment 3 to 4. That's the next number. That'll print the 4, right? If I keep repeating these. Print the 4, make it 5, dot, 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 all the way until it prints 10, right? Prints 10 and increments 10 to 11, and I don't want to print 11. So I need to make a condition that's true. Oops. I need to make a condition for my while loop that's true as long as it's a number that I care about printing, but the second it gets out of that range, like 11, I want to stop. So here's kind of the idea. You want to print I as long as while it's, right, less than or equal to 10. So that's that idea. So let me show you how that code would look. So it's going to be while I is less than or equal to 10, because that's my good values. The second it becomes 11, it'll stop the loop because it'll become false. Okay? So let me show you that. I'll make one big file with a bunch of different loops. Loops.py, that's what we'll call it. So let's do exactly that. There. So I'll start my I variable at 1. That's the first number I want to print. And then while I is less than or equal to 10. See how I'm thinking about it? Because it's going to be counting up. I don't want it to stop once it gets 11, though. So 1 is less than or equal to 10, 2 is less than or equal to 10, 11, though, is not less than or equal to 10. I want to repeatedly, though, while it's a good value, print my current value of I, right? So it'll print the 1 first, and then get ready for the next round. Then make I 1 more. I equals I plus 1. That's incrementing it. Okay. And so you see this will keep on doing what I said, what I drew here. And so the first time I'll print 1, then I'll make it I 2, and it's always going to come back to the condition. It's always condition, run the body if it's true. Is 2 less than or equal to 10? Yes. So it'll print 2, make it 3. So let me show you this running first. And we'll talk about it some more. So it does do the right thing. So the first time, like I is 1 less than or equal to 10. It's always condition, checks the condition, runs the body if it's true. So 1 is less than or equal to 10, so it'll print the 1, make it 2. Then we come back. It's always condition body, condition body. Is 2 now less than or equal to 10? Yes. So it prints the 2, there it is, makes it 3. Comes back. Is 3 less than or equal to 10? Yes. So it prints the 3, makes it 4. Right? All the way until prints 10, right? I is 10, it prints the 10, makes I 11, and then it checks, hey, is 11 less than or equal to 10? No, false. So it stops the loop. Okay? Does that make sense? That's what's going to happen. That's how we think about it in Python. Cool. We could do this in reverse too, couldn't we? We could print from not 1 to 10, but from 10 to 1. Can you think of how you might do that? What should be the starting value? If I want to print from 10 to 1, what should be the starting value of my I instead of 1? If I want to see this output, 10, 9, all the way to 1. What do I want to do? I want to start my I at, what do we think? With this idea in mind. If I want to print in reverse, not from 1 to 10, but from 10 to 1, where did I kind of say the first thing that was ever going to get printed? See, I said on the first line there, I started at 1, because that was the first thing when I jumped into here. That was the first thing that got printed, because I was initially set to 1. So if I want to print 10 first, you see how I better start at 10? So I want to do that. And so I need to, it's kind of going to be this idea, right? Repeatedly, what do I do now? Repeatedly. I want to print my I, print my 10, and then don't make it 11, right? The next number I want to print is 9. So not increment I, but decrement I. You see that? Cool. So make it 9, print the 9. decrement 9 to 8, right? Keep coming back. Print the 8. Decrement it to 7 until you get to, like, eventually you can imagine you're going to get to 1, right? You'll print the 1, make it 0. We don't want to print the 0, though, so we have to have a condition that's false when we hit 0, but true up through here. See that? That's what we have to think about now. So if you think about it, we want to keep printing while what? This is what is going to be our condition, right? Want to keep printing while what's true about I? Printing while something involving I. For this one, it was I is less than or equal to 10, right? That's not going to be good enough for us here, right? Because, like, yeah, it's true. 10 is true. 10 is less than or equal to 10. 9 is less than or equal to 10. But 0, right? 0 is also less than or equal to 10. See that? That's not good enough. So my hint to you is that usually it's going to involve comparing your number in some way to the last value that you wanted. Just like we were comparing against 10 here because we were going up to 10. Because we're going down to 1, we should compare against 1, right? And so what's true about I and 1, while it's 10, while it's 9, all the way to 1, but not when it's 0? If you think about it, well, it's always bigger than or equal to. You see that? It's always going to be bigger than or equal to 1. If it's 10, right? 10 is bigger than or equal to 1. 9 is bigger than or equal to 1. 8 is bigger than or equal to 1. 1 is equal to 1, so it's bigger than or equal to. But the second it gets 0, 0 is not bigger than or equal to 1. So if you're working your way down, it becomes a greater than kind of check. But if you're working your way up, it's a less than kind of check. So it's a bit opposites, okay? It's a bit like opposites here. And so this will be a good file to study once I give it to you. So here, let me section off the code and let's do this loop now, all right? So it's going to be the same idea, but we're going to print in reverse. So while I is 10, starts at 10, I want to keep printing while it's greater than or equal to, greater than or equal to 1, print the I and then decrement I. So not increment, decrement. Okay? And so that will print 10 to 1. Ooh, there it goes, after printing 1 to 10. Does that make sense? Are there any questions why this code corresponds to printing in reverse order? So it's definitely a pattern that you get used to. It's like, all right, start I at your first value and have a condition involving your last value. If you're counting up, make it less than. If you're counting down, make it greater than. Because if you flip this, right, it would have been an infinite loop, essentially. Or actually, this one wouldn't have actually ran because 10 is not less than or equal to 1. Sorry. So sometimes, though, it will become an infinite loop. So you got to watch out. But those are those two. Let's do one more. Let's do a summing example. Let's do an example where we can sum values. So let's sum up the numbers from 1 to 10. It's very similar to printing, right? It's just instead of printing out things, we're going to like put into another, like a sum variable, okay? So it's going to be the same idea of printing from 1 to 10, but we're going to like keep our sum variable in a safe place. And have another variable. Let's call it sum. Started at 0, so it's just like we were doing in Scratch. And then have our I range from 1 to 10 as we were doing. So like started at 1. Instead of printing the 1, it's going to be put the 1 into sum, right? And then make I2 get ready for the next number I want to put into sum. So if I just repeat that, right? Add I into sum, so add the 2 into sum, now it makes 3, and then increment I to get ready for the next number I want to put in there, okay? That's going to be the goal. And so, yeah, eventually now, like added the 3, now it's going to be 6, right? And make it 4, all the way to 10, right? We're going to add in the 10, and I think it's going to eventually be 55, right? You add in the 10, it makes up to 55. And then you make I11, but you don't want to add the 11 in. So again, you're going to have to stop, but we've already taken care of that with the way we ranged it, right? So if we just change this line and mess with the sum variable, we will sum from 1 to 10 instead of printing from 1 to 10, okay? So that's going to be the goal. Let's steal this code then and kind of do that. Do it down here. So let me section it off again so you can see the different pieces. But for this one, we have to also start a sum variable at 0, all right? That's our other idea. So sum starts at 0. I starts at 1, and just like keep on adding all the I know, right? I, given these other lines, is going to range from 1 to 10, and so I just want to take that I value and shove it into sum. Sum equals sum plus I. right? Put in the 1, make it 1, put in the 2, make it 3, put in the 3, make it 6. It just keeps on counting up. Does that make sense? It's just the scratch example that we did once upon a time all over again. And then by the time this is done, right, I will become 11, but I'll stop the loop. We won't actually accidentally put it into sum or anything. By the time this loop is done, then we have a value that we care about in the sum variable. So sum now holds, by the time we get out here to this unindented code, right, sum now holds the correct sum of 1 plus 2 all the way to 10. Okay, that's what's going to happen. And let us confirm that by printing it out. So I print the sum variable. So it did all the work itself. It didn't print anything in the loop. It was just building up an answer. And then we can print out that built up answer 55. Okay? Cool. I think, yeah, that's what I wanted to say for all that. Are there any questions about that example? This will be a good file to study when I give it to you after class. All right. So if we're good with that one, let's talk about combining lists and loops. Because lists, it's like, all right, I've got a bunch of stuff in a list. Let's go through all of it and like do math with it. All right, so you can iterate through a list using a while loop, can't you? Because what are these? You can get to each piece with an index, right? And we know how to make numbers count up. Like start at 0, then make it index 1, go to index 1, then go to index 2, then 3, then 4. Like we can just have a counter variable again, an index variable, and go to that particular index. Does that make sense? So your first index is always going to be 0 for no matter what your list is. And then how can you tell? Can you see how you might be able to tell, like, okay, the last index of this list is 4. I want to go up until 4, no bigger. Whereas, like, if it was a little bit bigger, 6, 7, or whatever, then I want to go up to, like, index 6. How can you tell the difference? It's going to involve, like, the last index changes depending on the size of the list, you see? So your last index for this particular size 5 list is 4, and that pattern is always true. It's always one. The last index is always 1 less than the size of you, right? So no matter your list, the length of it minus 1 is your last index. So that will be like the length of this particular list. X is 5, and so 5 minus 1 makes 4. Okay, so that's going to be your secret. That's what you're going to use. Okay, so you never forget that. That tells you your last element's index. And yeah, you can go through each index now with a while loop. Just like we were printing out numbers, we can use I not for like iteration value. We can use it for index value. That's why we like I, kind of. So I start at 0. That's the first index I want to visit in this list. And then I just want to keep on trucking, right? While I is less than or equal to the length of the list minus 1, do stuff, right? Because then I will be a valid index value. I can go there. I can do something with x at index I. You can use a variable as an index value. Won't that be cool? And then just like get ready to go to the next index. I equals I plus 1. So that's going to be the secret for iterating using lists. Okay. So let's see here. I think that's what I wanted to do. So let's make a giant list that we just want to go through, and we'll print out every piece of it. Okay, every element. I'll make a list here. I'll make a list called L, and I'll have it hold a bunch of numbers. It'll be like 5, 6, 7. They don't have to be in order though. 8, 9, about 1, and then like 13 or something. So like a bunch of different numbers. And I'd like to visit every element of those lists, of this list L, in order. So starting at index 0, then index 1, 2, 3, all the way until the end. All right, so the first index I want to visit is 0. So I'll start my I at 0, because 0 is always the first index of every list. Okay, and then I want to keep going. I want to keep on using I while it's a valid index value. So while I is a valid index value for my list L, so while I is less than or equal to the length of that list minus 1, right? What is that actually? So this is 1, 2, 3, 4. This is 7 numbers, so it's going to go up to index 6. 6 will be the biggest index I want to go to, right? So remember that len will tell you the size of your list, and subtract 1 from that. It gives you the last index of any list. So when you want to go up to of every list L. All right, so that's how you remember that. And then now we're just counting, right? We want to do something. Like here's how the loop is going to work from now on. It's like do stuff. We have an index I to work with. Go to that place, right? Do stuff with L of I. L at index I. starts at the first index, then goes to index 1, then 2, then 3. It'll go through every valid index. And then we want to increment I, right? Increment I to be ready on the next round to go to the next index, because otherwise we'll have an infinite loop, right? So like, what do we want to do here? Maybe we just want to print the list in order. We can print L at index I, and then get ready. If we start at index 0, we want to go to index 1 next, so I equals I plus 1, as usual, to advance us. Get ready to go to index 1 next, index 2 after that, index 3 after that. So I will always be looking at whatever current place I'm at in the list. I'll always be looking at the current index I care about dealing with right now. Does that make enough sense? Any questions about that? So this code is going to print these numbers from this list. It's going to go through that list and print them all out in order. So there we are. We got the 5, 6, 7, 8, 9, 1, and 13. And whatever random order that they were there, it's going in that order because those are the indices. Indices start at 0, then 1, then 2. It's going to all those places. Okay? That's why we see that output at the end there. Any questions about that now that you see what's happening? Think you can understand it? Alright, so yeah, this will just be this is a bigger file, right? So it'll be a very good file to study. Good practice with loops, okay? But if we are happy, I'd like to do something fun, right? Let's take that program that we were working on last time. That was drawing squares, like 5 squares. It was disgusting, right? Because we had to like duplicate the code because we didn't know loops yet. Let's fix that because we know loops now. So let's just like make a loop that loops not 5 times, let's do 50 times. So then it'll draw 50 random squares, okay? And then let's also learn how to do random colors, okay? I'll show you that too. We're just going to loop 50 times using like an I variable or something. Doesn't have to be I though. It could be anything. But let me open up the code from last time and I'll make a new version of it. All right, so let's go here. Where was it? Random squares, what I called it there. Boop. So I'm going to copy this. That's from last time. And then I'm going to make a new file in this times folder called random squares also. And then I'll steal all the stuff that we had before. But do you remember how disgusting this was? So we asked the user at the start what color they wanted. Like, let's keep that for now, like red. And then to draw a bunch of random squares of that particular color, we were just repeating this code, right? Starting my square side length. Go there and draw the square with the fill, begin, fill, and unfill. I just duplicated that code 5 times. It was disgusting. We can now fix that, all right? So let's get rid of all but one of them. All right, so let's just take just the first one. So this is code, right, that draws a single random square. Yes? I want to repeat that in a normal way using a loop, okay? So here's kind of the goal. I want this to be the body of a loop, so I'll indent it. See that? I'll indent it. So I'll say, I'll be like I equals 1. While I is less than or equal to, let's do 50 times, right? I is less than or equal to 50. We'll count up from 1 to 50. Just like we were counting up from 1 to 10, right? Let's do from 1 to 50. And then, all right, repeat this code 50 times. And we also have to increment I, remember. We're not done. So I equals I plus 1. So like I starts at 1, then it becomes 2, then 3. So we're not actually using I for anything other than keeping track of how many squares we've drawn. Does that make sense? We're just using I as a counter. We're counting up. So this loop, because of the way we just did it, can't forget the I plus 1. Otherwise, it'll just like be 1 forever, never get to 50. Now it'll be 1, then 2, then 3, all the way to 50. So it's counting from 1 to 50. Those are 50 separate numbers. So this loop, therefore, will run its body 50 times. Does that make sense? It's going to run 50 times now. And it's still going to pick a random, sorry, it's not picking a random color yet. I can still, let's do orange this time. It's at the start that we chose that. But look, now it's going to print, or not print, I guess it's going to draw 50 squares because we're repeating that body 50 times. So I have a smaller program than before, and I'm drawing 10 times as more squares. You could easily add more, change 50 to 100 if you wanted to. So this is very slow, and there's a way, if you remember, to control the speed of the turtle. So let's look into that now. It should just be called speed. You say turtle.speed, and then you give either a number or a string. So we'll give the string turtle.speed fastest. And then we'll make him go as fast as humanly possible. unless you do some other weird trick. So in addition to Mr. Turtle to looking like a turtle, please also have some coffee and go as fast as possible. Bam. Take an energy drink. All right. So now he's gonna draw very fast after I give him a color. What? I guess we're on yellow, right? I did red and orange, yellow. So there he goes, super fast, fastest. He's gonna draw 50 squares of random sizes and locations. Pretty. And you can center this better. It's just like he's doing it in that like corner of the screen because of the way I picked random numbers, -200 to 200, and that was always meeting the bottom left of the square. It wasn't really the center of the square, so that's why it's a little offset. So you can fix that if you want to, but that is the secret, and it's beautiful, isn't it? We can make it better, though. Instead of asking the user for the color, let's do a random color, okay? Let's do that. And now I need to teach you how to get a random color. The secret is going to be lists, all right? So instead of like asking the user what color they want and using turtle.fillColor that, I'm going to do turtle.fillColor random color this way, okay? So before I draw a square, every time I draw a square, let's pick a new random color each time. So I got to do that in the body. Pick a random fill color. Here's going to be the secret, all right, to doing that. What we're going to do, because like fill color, you say turtle.fillColor, right? Fill color. With a string that represents the color you want, red, orange, yellow, green. So let's have all of those be options in a list. See where I'm going with this? Like, let's make a list called colors and have it like have whatever colors I care about. Red, orange, let's do all the rainbow. Orange, yellow, green, blue, purple. There's more, but that's good enough. So I have a list of a bunch of colors, and I want to pick a random one out of this list, all right? So we can do that now, can't we? Because we know this is index 0. I can just pick a random number and go to that index. Index 0, index 1, index 2, index 3, index 4, index 5. So I just want to pick a random number between 0 and 5. Does that make sense? Go there. I've got a color. That's beautiful. Cool. So I just need a random index now. So random index is random.randint between 0 and 5, right? And if you didn't want to count, you could have done this, right? What's the last index of any list? It's always the length of that list, -1. So this will give me a valid index, a random valid index of colors. Does that make sense? And then I just need to go there. Go to that index, colors at that random index. Could have been 0, could have been 1, could have been 5. And that will pick out, like maybe it was 0, and it will pick red, right? It'll set the fill color to red. Or if the random index was like flipping a coin, right? Or like it's rolling a die. If it was 3, it'll be like, we'll go to index 3. Colors of 3 is 0, 1, 2, 3. That'll be green, and it'll set the fill color to green for this particular round of the loop. Does that make sense? How it's going to be different every time? It's picking a random color every time before it draws a square. That'll be really cool. All right? Any questions about why that's going to work? It's going to pick a random color because of that. It's going to a random index of a list. Now we know all those pieces. That's what we needed before we could do that. So now we get some really cool looking artwork. Beautiful. And it's different every time. It is very, it's like extremely, ridiculously unlikely that you'll ever see those colors in that order ever again, right? Because of all the randomness involved. So I will never see that exact artwork ever again. But I think it's really pretty, right? So what it's doing again is, as it's working, it's picking a random color, right? It's looping 50 times. As long as I is between 1 and 50, it's incrementing each time. It's going to pick a random color, right? Let's keep it rerunning to keep the intrigue going. Pick a random color, and then start like picking random side lengths and bottom left corner coordinates for that square, just like we were doing last time. And just like draw the square. Remember that we've drawn one, increment, so that we eventually stop. Right? So you can change this to draw 1,000 squares if you want to. Change like the randomness, but that's the secret. And I'll give you this code for fun. Are there any questions about why it's working? It's going to loop 50 times. Say that you're saying that there's another way to get colors randomly? You do. There are ways. Yeah, there's other ways to choose colors in Python, and you could use random numbers for those. Here, let me show you. Fill color, for example. Yeah, so you know, are you familiar with the RGB color system? So like, yeah, some people use numbers like if you're a web program like FF00FF or something. Have you seen that before? There are numbers correspond to colors inside of a computer, and so you can pick a bunch of random numbers like how much red do you want the color to be, how much green do you want it to be, how much blue do you want it to be. And so that's that. Then you have millions of options for colors if you do it that way. So look into it's called RGB. Yeah, so you can give them looks like this as well. But yeah, if you want to have completely random colors, look into the RGB color model. It's very fun. That's what if you ever took a magnifying glass to a display before, you can see like the red parts, the green parts, and the blue parts. That's just how computers deal with colors. So yeah, it's a fun idea. Nice question. Any other questions? Does that make sense though? That's what we'll be doing there. But yeah, if you want, you can just make a big long list of every color you can think of. There's a big long list of colors somewhere that it knows about. And there's more than just this. Just like search Google for like which color strings can Python turtle handle. Let's see here. I should say it somewhere. Fill color. Somewhere in this documentation page, somewhere on the internet, it will link to a bigger, longer table that you could use if you want to. And I'll show you that in a future assignment too. But yeah, I think this is a fun example. And I think that's the last thing that I wanted to show you guys today. So are there any questions about this code anymore? I'll give it to you, so definitely play around with it. It's very cool looking. It'll make some pretty artwork, some pretty abstract art. And yeah, you might be able to use these ideas to help you in your assignment, right? Where you're doing just a few triangles, right, instead of squares. So yeah, I think that's what I wanted to say for the lecture today. And I will give you a programming assignment. Just as a sneak peek, I do have a link in this one. Whee! I'll release it though on Wednesday, but here's all the different colors that it knows about. Orchid, dark olive green. Like you could make a list of all these colors if you wanted to. So I'll give you that link on Wednesday. Okay, but I think that is all that I wanted to say for today.